Alright, so in this video I want to describe covariance and specifically the covariance of discrete random variables. So first of all, covariance is just the tendency between one variable's value to change and whether that will affect the other variable's value. So if we have a positive covalence, it means that if one value changes, the other variable's value will change in the same direction. And this is the opposite for negative values. If, say, variable x increases, then variable y would decrease. And finally, if the covariance is 0, it means one variable's value changing will not affect the other variable's value. So like for example, if someone drinks coffee when they wake up in the morning, like they're tired, if we change the variable of when they wake up, then there's going to be a change in how much coffee they drink. So if I'm waking up at a later time, there's going to be a negative covariance between how much coffee I drink and how late I wake up, because when I wake up later, I'm going to be drinking less coffee. So one more thing I want to say before I go into example is if two variables are independent, then their covariance has to be equal to 0. But if a covariance is 0, it does not necessarily mean that the variables are independent. And we're going to get into that right now. So first of all, the covariance formula is the expected value of x times y minus the expected value of x times the expected value of y. And if we look at just our example, we have x as a discrete random variable with values -2, 0, and 2, and they all share the same probability. And we find that y is completely dependent on x. Y equals x squared. So to find the probabilities of y, we just plug in our values of x and see what values we get. And we find that y will be 0 1/3 of the time, and y will be 4 2/3 of the time. And to solve for the covariance, we just find the expected value of x, the expected value of y, and the expected value of x and y, which is just done by multiplying every single value of x, y, or x and y by their respective probabilities. And we find that the expected value of x is 0, y is 8/3, and x and y is 0. Now we plug that into our formula and we get 0 minus 0 times 8/3 equals 0. So the covariance is 0. But what about independence? We know the independence is the probability of a and b, or x and y in this case, times the probability of x times the probability of b. So we look at just random numbers. The probability of x equaling 2 and y equaling 0, well, that's impossible. So its probability is 0. But we know, reading from our table, the probability of x equaling 2 is 3. Probability of y equals 0 is 1/3. And we multiply them together and we get 1/3. Now 1/3 doesn't equal 0, so they are dependent. So what is going on here? Well, the thing is, it's all coming down to y being 100% dependent on x, and x having a symmetrical distribution. This symmetrical distribution is what's causing the expected value of x and y to equal 0, because y only depends on x and it's symmetrical, it's going to even out at 0, and the expected value of x alone is going to even out to 0. And when you multiply them together, you get 0 covariance overall, despite y being 100% dependent on x.